Now let's do some review of what we've learned about graphing. Let's begin by solving an equation for x. Because we see the parentheses here, the first thing we want to do is distribution to remove the parentheses. That's going to give us 2m minus mx is equal to 7 minus y. And then we're trying to isolate this x by itself, and it's got this negative m in front of it, and I would rather not have a negative value in front. So I'm going to add this mx to both sides of this equation so that we can have a positive mx on the right side of the equation. Now we have 2m is equal to 7 minus y plus this mx. Now let's subtract off the 7 on each side and add a y to each side also, so that we can just have the mx by itself on the right. Now on the left we have 2m minus 7 plus y, and I think when I rearrange this I'll put the minus 7 at the end, is equal to mx. That's m times x, and we want the m by itself, so we're going to divide each side by m. There we go. Let's divide each part by m separately. That way we can cancel out in this first fraction, and we can have 2 minus 7 over m plus y over m. I guess I'm not going to move that minus 7 to the right, is equal to x. Now that's one of only a variety of ways of how we can write this solution or this equation written in terms of x. In which quadrants is x greater than 0 and y greater than 0? Well, that's just another way of asking where is x positive and where is y positive. And it's only in the first quadrant that both x and y are positive, so our answer is that this is going to be in quadrant 1. Now, in which quadrant is the product x times y positive? Well, let's take a look at what x and y are in each quadrant. For x, we're going to have a positive value of x over here and down here in that quadrant, and it'll be negative over there. But for a y value, the y's, we're going to have positive in the upper quadrants and negative in the lower quadrants. So the question is, when will this product be positive? Here it's positive, and down here negative times negative is positive. So our answer is quadrant 1 or quadrant 3. In these other two quadrants, a positive times negative is going to make a negative, and we do not want quadrants 2 or 4. When it says graph x equals 2, we notice that we're missing a y. We can't have a y equals anything for this equation. So the rule is x is 2 no matter what y is. So here I've plotted x is 2 when y is 0, x is 2 when y is 1, and that might remind us that this is going to be a vertical line crossing through the x-axis at 2. This next equation is in slope-intercept form. If we were to substitute 0 in for x, 2 times 0 is 0, minus 5 is going to give us negative 5. So when you substitute 0 in, we have a negative 5 as a y value. When you substitute a 1 in for x, 2 times 1 is 2, take away 5 is negative 3. So at 1 we have a y value of negative 3. And that's the info you need to be able to draw in your line like that. Graph these two equations on the same graph. Notice they both have the same 1/2 in front of x. Both of these are going to have a slope of 1/2. Now let's start by plotting by just creating an xy chart here. If you substitute 0 into the first line, 0 times 1/2 is a 0, plus 2 is 2. Let's substitute 2 in, because 2 times 1/2 just makes a nice clean 1, plus that 2 makes 3. So this first line is going to go through 0, 2, and 2, 3, and we can draw that line in like that. The second equation, let's use the same two input values. Let's start with 0. 1/2 times 0 is 0, take away 1 is negative 1. 0, negative 1 is plotted 1 unit below the origin. When I substitute 2 in for x, a half times 2 is 1, minus 1 is 0, and we're going to have a point at 2, 1. When I graph these two lines, notice they both have the same slope, and notice they're parallel and they're never going to intersect each other. For problem number 7, let's again use an XY chart this time, and because I've got a fraction with 3 in the denominator, I'm going to use 0 and 3 as my two input values. Anything times 0 is 0. Add the 1, we get 1. Now when I go 3 times this negative 2/3, the 3's are going to cancel. I'm just going to have negative 2 plus 1, making negative 1. So 0, 1 is 1 unit above the origin, and 3, negative 1 is 3 units to the right and 1 unit down, and therefore we have these 2 points, and we can play connect the dots as best as we can here to draw this line. Graph the line passing through 2, 3. Okay, I can automatically plot that point with a slope of negative 1/2. So I'm going to go down 1 and over 2, and that will be another point through which this line goes through. And I can now play connect the dots and draw in our line that way. Write the equation of each of these lines. Well, right off the bat, I see in this first line I've got a y-intercept at negative 2, and it appears to be going up 1, 2, 3, 4, and over, well, it's kind of hard to read here. Maybe that's a better point to identify. So up 1 whole unit, 2, 3, over 1. So it looks like my slope is going to be 3 over 1, or 6 over 2, depending on how we do this. Up 2, up 4, up 6 over 2. So if I'm just going to put this together in y equals mx plus b form, I'm going to have y is equal to 3x minus 2. In this next equation, I have a y-intercept which looks to be at 2, 0, 2. And here I have 1, 2, 3 as an x-intercept, if I wanted to write it that way, 3, 0. But I can see I've gone down 2 units and over 3. So I'm going to write a slope of negative 2/3. I don't really need the x-intercept. If I'm going to go with y equals mx plus b again, I'm going to have y is equal to negative 2/3 x plus 2. Let's work with this next equation and convert it from the standard form into slope-intercept form. Slope-intercept form is y equals this mx plus b. So we're basically being asked to convert this or solve for y. First thing I want to do is subtract 4x on each side of the equation. That's going to give us negative 5y on the left is equal to, and I'm going to write the negative 4x first so I can have my mx together, plus 8. That's not really m because we haven't divided through by negative 5 yet. But when I do divide through by negative 5, then I'm going to have the slope in front of the x just the way I want to have it. And so now we're going to have y is equal to positive 4/5 x minus 8/5. Let's do this again. Again, I want to isolate the y. We will be adding 2x to each side to bring that to the other side of the equation. Now we will have negative 8y on the left is equal to 2x plus 7 on the right. Dividing through by negative 8 in each position will then isolate the y for us, and we will have y is equal to negative 1/4 x minus 7/8. Find the slope between these two given points. Well, let's first identify them as x sub 1, y sub 1, and x sub 2, y sub 2. The slope formula, which I hope you have memorized, is m is equal to the difference of the y's, starting with y2, divided by the difference of the x's. Substituting those values in, our y2 minus y1 becomes 5 minus 7 in the numerator. Likewise, in the denominator, x2 minus x1 becomes 3 minus a negative 2. So our numerator becomes negative 2, and our denominator becomes 5, and our slope is negative 2/5 between these 2 points. Now we're being asked to graph an absolute value equation. Absolute value equations are always V-shaped, and if you're not comfortable with this, you can always use the XY chart. Now let's take a look at a few key values. Let's start with 0. 0 plus 2 is 2, and the absolute value of 2 is still 2. Take away 1 is 1. Let's try negative 2. And now I choose negative 2 because I always want to choose the value that's going to make the insides of the absolute value 0. So negative 2 plus 2 is 0. Absolute value of 0 is still 0. Minus 1 is negative 1. That's going to turn out to be our vertex of this graph we're going to have. Now let's go down to negative 4. Negative 4 plus 2 is negative 2. The absolute value makes it positive 2. Subtract 1 and we have 1. So our 3 points, when we plot them, are 0, 1, 1 unit above the origin, negative 2, negative 1, and then negative 4, positive 1. And you can see we're going to have this V shape that we're going to draw here. Be careful that when you're plotting these, you always make sure you find the vertex. Know that an absolute value graph will always be V-shaped, and the vertex, at least the x value, can be found by finding that value that makes the absolute value equal to 0. Now it turns out that whenever we have an x squared graph, the graph will be that of a U-shaped instead of a V-shape. It'll be called a parabola. And what we want to do is we want to plot both positive and negative numbers, because when they get squared they both become positive, and that's an interesting feature. So let's start at negative 2. It squares to 4. Negative 1 squares to positive 1. 0 squares to 0. 1 squares to 1. Positive 2 squares to positive 4. And that gives us 5 points, which we can plot rather easily here. And notice we don't have a V shape, and that instead this is going to be a curved graph, and that is a parabola, P-A-R-A-B-O-L-A. That is a shape that you're going to get to know more and more as you move on through your math classes.